Welcome back, Cody's Auto Diagnostics. So I went through my files. I found a couple old case studies that are not old case studies, but some case studies that I want to share with you guys. So this right here, 2005 Ford Ranger, came in a couple months ago. Ended up getting front and rear brakes. They were metal on metal front and rear, or pretty close to metal on metal. They needed replacement. So what we ended up doing is we replaced the front rotors because they are out of specification, so we weren't able to turn them. Replace the front rotors, replace the seals, also replace the bearings. There was some pitting on the bearings. Replace the rear brakes, the shoes, turned the drums, replaced the hardware, and also performed a brake fluid flush. There was some moisture in the system. So fast forward a couple months forward, and the vehicle comes back, and customers' concern was that when applying the brakes, the last 5 feet of braking, the vehicle would lunge forward. Alright, I mean that's I understand that, so wanted to verify customers' concern, which this is when I received the vehicle. So verify customers' concern by test driving the vehicle and doing hard stops. Brakes were fine. Doing ABS stops, the brakes were fine, acting normal. It was the very slow braking, and the customer nailed it. I mean, the last 5 feet of braking under 3 miles an hour, the ABS would activate. You damn flies. The ABS would activate, and if anybody knows, what the ABS feels like when you're stepping on the brakes and stuff, the pump runs and it pulses the brakes. Oh my gosh, this thing is gonna kill me. Anyways, so verified customers' concern, and their description of it was pretty spot on. Thing is, I ran codes. I do not have any screenshots or data. This fly is gonna kill me. I do not have the screenshot or the snap-on, the data graphing of that. Wow. But anyway, so coming to a stop, it was doing it. It was not coding. No codes whatsoever. Okay, was not it. So it's doing a false ABS activation, and it is not setting any codes. And like I said, it is the last 3 to 5 feet of braking, of very slow light braking, is when it would activate. So I know we did rotors on it, and I know we did a bunch of work on this. That's one nice thing, that I do know the history of this vehicle when it came to the brakes and stuff, because this is a pretty good customer of ours. So not having any codes, I graphed the front wheel speed sensors, the rear wheel speed sensor, and there's no, it wasn't sending me in a direction of which wheel that I thought was at fault, which was causing this false ABS activation. So that's when you have to dig a little bit deeper. Scan data wasn't giving me that. So without getting too dirty and disassembling everything on this vehicle, I grabbed the Pico scope, right? And so doing that, I wanted to see what the wheel speed sensors are looking like on an actual scope, and not just the data PIDs on the scan tool. You have to understand that these data PIDs on the scan tool are a frequency measurement from the EBCM, from the electronic brake control module. It takes an AC voltage, it takes a signal, and enters from the wheel speed sensor, enters the ABS module, and that converts it into like a miles per hour that we see the PIDs on our scan tool. Okay, so don't laugh at my drawing. I am not an artist. But we have the tone wheel. The tone wheel is mounted, in this case it is mounted on the rotor. Other situations or other vehicles, it can be mounted on the ABS, or it can be mounted on the actual axle shaft, the CV joint. It can be, the tone wheel can be mounted on that. It can be inside of a hub assembly if it's a sealed bearing. There's a bunch of different ways that it can be mounted onto the vehicle, but this rotates as the wheel rotates. So right here, this right here is the speed sensor. So it's a 2-wire sensor, and these wires come up to the electronic brake control module / the ABS. Okay, so this sensor right here produces an AC. It produces its own voltage. It produces an AC voltage every time that it passes one of these triggers, these teeth on the tone wheel. Okay, so this is it. The voltage will go high, the voltage will go low, depending on where it's at. Think of these as windows, on and off windows. So it creates its own voltage. So you can essentially disconnect this ABS sensor and hook in a multimeter and put it on AC and rotate the wheel and capture it. But with a multimeter, a multimeter is going to take an average, and it's not going to show you everything like a lab scope. I grab my lab scope before I grab my multimeter, 9 times out of 10. So also, one thing that you do want to note here, this right here, the distance between the tone wheel and the ABS sensor is the air gap. And the air gap, it's going to be different on every single vehicle, but you want to make sure that the air gap is the same from passenger side to driver side on all the sensors. If you have one that's too far out, the amplitude of the AC voltage is going to be lower than the other sensors. So that could be an issue. But that's kind of a description of how an ABS sensor, 2-wire sensor, works. So creates its own voltage. So here's a picture of the truck. I'm going to try in this editing, the video capture, or the screen recording and stuff, so hopefully it works out for you guys. But first thing I wanted to check was the ABS sensors. Okay, so this is courtesy of the Snap-on scan tool, the Zeus. This is through the guided component test. It gives a little bit of information on it. So it's, like I said, it's a 2-wire sensor, so it's giving you the pinout right here, and it's telling you the left front wheel speed sensor positive and left front wheel speed sensor negative. Okay, so what I did, I didn't use the Snap-on, but I grabbed my Pico. Just a little bit more options and stuff you can do with the Pico. Having a scope is better than having no scope. That's my opinion. And the Snap-on is good, but it has its limitations. So that being said, so I like this because it's quick and easy I can get to. Even though I really didn't need a wiring diagram, it creates its own voltage. So what we want to do is we want to go in and we want to probe with our scope. I ended up just back probing. I didn't just disconnect the sensor. I back probed the terminal 1 and terminal 2. So it will create its own voltage. Alright, so moving on. Whoops. So moving on, so this is me hooking up the Pico. I have it hooked up, and I took the wheel and spun the wheel, okay, and walked over and grabbed this capture. And to me, the first look on this capture is, I mean, this is what you want to see. This is a good signal. Now, mind you, yes, I do not have this set on AC volts. If you look, it's on DC. The one nice thing about the Pico, you can plug it in and run with it. It doesn't have to be on AC. But just take note of that, depending on the scope and stuff you use. you may have to do that. Okay, so let's zoom in a little bit on this. And if you look at it, you can see these on-off signals. Okay, you can see where the wheel sped up to there, right? And then it just started slowing down. And then it sped up a little bit more and then started slowing down. This is the driver's side front wheel. That's not an issue to me. I see that and I have to continue on. So that is what you would want to see. Alright, so now moving on to the passenger side. So moving on to the passenger side is going to be in red. Zoom in on this. And if you guys can see, I mean, that right there. So, I mean, just taking that alone, got you. So just taking that alone, you can obviously see there's a difference. Okay, so this is what it should look like. And this is what we're getting out of the right front. So right here, it's saying that it's speeding up. Oh man, I didn't get you. I'm sorry, guys. Okay, so right here it's saying it's speeding up, slowing down, speeding up, slowing down. And this is me just doing it by hand, just one spin and letting it rotate. So that little bit of time doing that, it is seeing these abnormalities. I can't say that. You know, so it's seeing this. You know, if you look at it, it's actually a pattern. So you know, you have high spots, then you get a big low spot, another high spot, another low spot. I mean, it does not look like a smooth up and down like the driver's side. Okay, so let's zoom in a little bit more on this, and you can see it a little bit more, you know, so the up and down, the up and down. So that right there, if that electronic brake control module is seeing that, it's saying that this wheel is spinning a whole lot differently than this wheel right here. So it's gonna apply the ABS, because they're not matching. They're thinking that this wheel is spinning, or yeah, it's pretty much that wheel is spinning different than this wheel. So it applied the ABS, and that is the false activation that I was getting on this test drive. Okay, so my question is, what will cause these up and downs like this? You know, is that a sensor issue? Well, I mean, no, it's not a sensor, and I'm going to tell you why. So, not being a sensor, the thing is, this thing is, if you look at it, I mean, this thing's reading. I mean, this sensor looks good. I mean, it is reading, it's doing its job. It is reading what it is receiving. And when I say receiving, it's reading what it is seeing from that tone wheel. So if this air gap right here on the tone wheel, if it is crooked, if it is offset where it's higher on one side and lower on the other side, you're going to get highs, and then you're going to get lows. Because taking that magnet, that permanent magnet, that sensor, that speed sensor, and pulling it away from that ABS tone wheel, it's going to change the amplitude of the AC voltage. So that's exactly what we are seeing here, is that tone wheel is not perfectly centered on that brake rotor. So here's where it's good, and then the distance gets farther away, so it drops down, and then the distance comes back around, so it goes up, drops down, and mind you guys, this wasn't anything I was seeing whatsoever on scan data. whatsoever. I mean, I trust me, I looked, I zoomed in to make sure that I wasn't missing anything before, you know, I started breaking out the other equipment to scope this stuff. If I can fix it in the driver's seat, that more power to you. You know, you don't have to grab a scope for every single thing. In this case, it makes it nice because it's, I wouldn't have found this without the scope. Without getting dirty, I guess I should say. So now let's, so that's a definite issue. I have video, it's pretty shoddy video. I was trying to get a capture. I was trying to hold the light, get a capture, spinning the wheel, showing you guys that that tone wheel is actually off-centered. You can see it rotating as the rotor's spinning. So that's confirmed that that rotor is bad. Or the tone wheel placed on that rotor is bad. It just done a couple months ago. The right way to fix it is to warranty out that rotor and replace it with a new one. Now, did that rotor get hit installing the bearings? I mean, it possibly could have. Actually, I'll show you guys a picture. Possibly. Okay, so here is the old rotor. And it's real hard to tell from this kind of capture and everything, but this is, all right here, is where the rotor's good. Okay, this part right here where I have marked in yellow is lower on the actual rotor assembly. So it's cockeyed, right? So this is a low spot, and this is all where it should be. So this is what we're seeing. So this is where it's reading good. It gets to here, and the amplitude gets smaller. It gets to here, amplitude gets bigger. Gets around and around. So looking at that capture, we can see this thing, it's a pattern. I mean, it's doing up, down, up, down. I mean, that is a pattern right there. So if it's a pattern, there's something that's consistent that's causing that issue. It's not a sensor going bad. The sensor's doing, like I said, the sensor's doing its job. Now, one thing that I do like about the Pico, or there's a bunch of things I like about the Pico actually, but one nice thing about the Pico is the tools. These math channels, okay? We're going to create our own. Go into advanced, you hit frequency, and you choose the channel that you want to measure. In this case, it's the blue channel I want to measure, so I'm going to pick A. Go to next. I always pick a different color than what normally is loaded on the, which is a normal color for the Pico, like the green, yellow, red, and blue. So I normally go with black, just so I can tell it's a math channel. Hit next, next again, and finish. So doing that, you can see I've created a couple other ones. So frequency for channel A, frequency for channel B. So I have those created. Once they are created, you don't need to create them anymore. You can go in here and select them just like I did here. So these frequency channels are nice. Because like I was saying earlier, so the ABS sensor produces a signal, produces an AC signal. It goes into the electronic brake control module, and that electronic brake control module interprets that signal and outputs something different on what we see on our scan tools. And anybody that's ever graphed a wheel speed sensor going for a drive, it gives you your miles per hour, and it's a smooth, you know, up going fast and slow going down. It's not what you see the actual sensor doing. So can you diagnose vehicles with scan data on using just the PIDs, yeah, absolutely. In this case here, I wasn't able to. But there are times where yes, you absolutely can diagnose the vehicle or speed sensors or see something like this on the scan tool. But you have to think of it this way. So, and Scanner Danner has a great explanation for this. So, using the Pico scope and going directly to the sensor and reading what the sensor is actually doing, what that sensor is telling the electronic brake control module, that is front door information. Okay, so that's information going into the module. Now, what we read on our scan tool is backdoor information, and that backdoor information is information that's interpreted by the electronic brake control module, or any module for that matter, ECM, PCM, BCM, I mean any kind of module, right? Using the scan tool, that's backdoor information. So front door is, you go to the front door, you're seeing exactly what's getting input to that control module. And backdoor information is just that. It can be there is times that the control module, any control module for that matter, will either misinterpret the information or they're outputting a different kind of signal. It's like a crank sensor. You go directly to a crank sensor and you see, you know, the 0 to 5 volt square waveform. That's nothing. You're not going to find that on a scan tool. There's no PID for that. I mean, you may have an RPM. You know, you're going to have an RPM PID, but that's not telling you anything. I mean, that's telling you if there's RPM, but that's not telling you exactly what that sensor is doing. And that's the importance of a scope. I mean, it's having a scan tool diagnosing vehicles. Trust me, I did it for a long time. But just doing that, unfortunately, there's times that you're not going to see everything, and that's where having a scope, it's a must. I mean, anymore with these electronics and stuff, you can't just diagnose a vehicle on scan data alone. Scanners have gotten better. Don't get me wrong; they have gotten fast. The bidirectional controls to the displays. I mean, they have really they've come a long ways. But there's always going to be a need for a scope, okay? And could this have been figured out without a scope? Yeah, absolutely. And I'm not sitting here saying that this is the only way to figure it out. I'm just giving you guys. I like seeing things. I like, you know, I can print this up for the customer and be like, this is different than that, and they don't have to know anything about cars to be like, yeah, that's different. Well, that's your issue. Oh, okay, I get it. Okay, cool. You know, it just, you know, simplifying it for customers. I like seeing it. You know, presentation's huge. It makes them build confidence and stuff in you. So anyway, that's enough rambling about the scope. So I added these math channels. Right now you cannot see them. They are down here. So there's a couple ways to zoom on the Pico. This is one way. So I'm going to bump this up to 7. I'm going to do this offset and just ramp this up so we can get it onto the screen here, and it will eventually pull this up. I'm going to drop channel B down. I'm going to drop this one down. And so what I have here, this black channel, this is the hertz. This is like the duty cycle, or the hertz of this measurement. So this is what the scan tool converts our signals to. Doesn't this look like, you know, the miles per hour up, getting faster? Now we're slowing down. Over here, getting faster. Now we're slowing down. That's what we see on our scan tools. We don't even, you know, didn't even see this hump right here. I mean, it didn't even pick up this right here, okay? You know, speed up, slow down. And that's what we see as far as that. So now let's go to the channel B. I'm going to do the same thing. I'm going to ramp this up to 7. Just another way of zooming, and take this offset all the way up. And I just want to show you guys the difference on this. And we will take both of these here. Get this one out of the way a little bit. Move this one up. So this is nice. Like I said, I didn't have an issue with channel A here with the driver's side. The wheel sped up, the wheel sped down. Okay, so here on the passenger side, on channel B, you can see the frequency drop out. And it's not even dropping out on every single one of these dropouts here, but it is, you know, it caught it here, missed it here, caught it, missed it, caught it, missed it. But right here, I mean, it's telling you, you know, it's speeding up. Oh, it just dropped out. Okay, bring it back. Oh, now it just dropped out again. So, you know, that right there, this is what we're used to seeing on our scan tools. A PID like this, and it will usually be labeled in miles per hour. So as you speed up, the miles per hour will change. If you're going 45 miles an hour, usually all 3 or all 4 wheel speed sensors are going 45 miles an hour. And you can usually see when one drops out, and if you're going, you know, 15 miles an hour and one drops out and it goes to 0, obviously that's an issue. But this right here, this, you know, this is more detailed than what your scan tools are gonna capture. So that's that, right? So now let's go to after the repair. So I showed you guys the rotor, the low spots and everything on it. So the fix for this was replacing the right front rotor. Free of charge to the customer. It's under warranty. I didn't see any hammer marks on it. I didn't see where it was a defect on our end installing it. These rotors come with the races already installed, so it's not like you're hammering in races. The only thing you're doing is tapping in the seals, the grease seals a little bit. You're not even hammering on it super hard. So I didn't see a defect on our end. But this is one that can kind of, if you don't know a system, I mean, I know this is pretty simple for a lot of you guys, but I mean, if you don't know a system, this can really throw you for a loop. So it's just understanding, and that's all I'm trying to do right now. So here is the after. Okay, I'm going to zoom in on this. This is after the rotor replacement. Driver side, passenger side. Okay, so obviously the wheel spun a little bit differently, but you can see there's no huge dropouts. You know, it sped up, slowed down a little bit, sped back up, slowed down, faster, and then slowed down. So same kind of thing over here. You know, that looks nothing like it did in the previous capture with the actual dropouts. Okay, so let's do the same thing with those math channels and see kind of what it shows. So I already have them. Like I said, I've already created them, so now they're in my math channel library. So I just have to go in, frequency A, frequency B. I just hit OK. So I'm going to do the same thing, and I'm not sure why it's blacking out the screen like that. Maybe one of you guys can help me with that. So go up to 7. I'm just taking this all, you know, and I'm just choosing 7 just because it gives it a little bit, makes it taller, makes it a little bit easier to see for you guys. So I'm going to do the same thing on this channel over here. I'm going to bump that up. I'm going to take the offset all the way up. And we want to see kind of how it looks. So I'm going to just zoom in here Oops. Okay, so look at that. I mean, this is like I said, what we're used to seeing on our scan tools. Miles per hour go up, miles per hour come down. And if you see, there's no more dropouts, there's no more glitches. And even though this isn't perfect, and there is, you know, some dropouts and some glitches and stuff, the frequency, it's not registering that. I mean, it is not catching that. So it is, so if this is not catching it, do you think the electronic brake control module is catching it? I'm gonna sit here and say if this is showing good, then yeah, the electronic brake control module is not gonna see an issue. I mean, it doesn't see an issue with this one, and it doesn't see, the frequency math channel does not see an issue with the other one. So right there, that's a fix. New rotor took care of that issue. I mean, I've had some false ABS activation vehicles that have just kicked my butt for a minute. Longer, definitely longer than it should have. And it kicked my butt longer than it should have because I wasn't using the lab scope. And at that time, I didn't even have a lab scope. So I'm just going off of scan data. And scan data will get you so far, right? That's where scopes are nice. I don't want this to be a super long video. It's a pretty simple case study. But it is, you know, it's pretty sweet. I mean, these math channels, this isn't anything that the snap-on scopes do. You know, Pico is, I would say, you know, top of the game when it comes to the lab scopes. Are you going to be able to pick up these kind of signals as far as the AC signals from the wheel speed sensors on a snap-on scope? Absolutely. Absolutely. You are going to see this. Are you going to be able to add the frequency? No. I mean, it's limited when it comes to that. But the snap-on scope is good. You know, just the AES U-scope. Awesome. I mean, having a scope is better than having no scope. And you guys, I mean, if anybody does drivability or diags and stuff, will know that, yeah, there's cars that you get that you know right off the bat kind of what it is. I mean, within the first 10 minutes or the first 5 minutes of reading the code, you know the direction to go. Well, what if there is no codes? What do you do? Is that where it throws you guys for a loop? Is that where, you know, if it's not coding, you don't know where to go? I mean, obviously this was ABS, and you know, it generalizes it. You know, there's an issue with the brake system, but there could have been a bunch of possibilities for this. Like I said, pretty quick, pretty simple. Video is way longer than I thought it was going to be, but I definitely wanted to give you guys some detail of it. Something to look out for. Being able to use those math channels. Those math channels come in super nice. I mean, I really enjoy using those. Actually, I should probably use them more than I actually do. And so yeah, I mean, thanks for watching, guys. This was you know, 2005 Ford Ranger false ABS activation. I have a bunch of other files. Try to get you some more case studies. Hopefully this kind of format will work for you guys on some case studies or whatever. Still, like I said, I'll still try to bring you guys into the shop, let you guys know what's going on. I also do want to give a shout out. Not sure if you guys can see this. Let's see. But Joe's Auto Electric, he was nice enough to send me a sticker. He also sent me a magnet. Top-notch dude right there. I mean, everybody that I met with all the networking, all these other channels and everything, just, you know, really great guys. So you have a sticker, you want me to post it onto the fridge, send it to me. I'll do that. I'll put you in a video. Just like everybody else has for me. So, you know, greatly appreciate you guys watching. Thank you guys so much. And until next time, we will check you later.